Hello friends, in this video I am going to show how to draw a stick diagram of a XOR gate in static CMOS logic. So first of all, I have made a schematic of a static CMOS XOR gate as you can see here. Now the next step is to identify a Euler's path. Euler's path in a graph is defined as a path through which all the nodes of the transistors such that each edge in the graph is only valid once. For example, there are two Euler's paths which can be recognized in this PMOS, such as this path and this other path. The two paths are A, B bar, A bar, B. The other one is B, A bar, B bar, and A. Now, we can choose any of the Euler's paths to draw our stick diagram. In this video, I will choose this path to draw the stick diagram A, B bar, A bar, B. Now the first step is to mark the VDD and the ground region. For that, we can make two lines which will correspond to VDD and ground region. Now the second step is to mark the source and the drain region. As we know, for the NMOS, the drain is up and the source is down, and vice versa for the PMOS. Now the next step is to mark the NMOS and the PMOS in this for one line of PMOS stack and the other line of NMOS stack. And then we have four transistors here. The four transistors will correspond to these four lines. Now according to Euler's path that we choose, that is A, B bar, A bar, B, I'll mark it as A, B bar, A bar, and B. Now the first thing is that I need to see the regions which are matched. The drain region of the A transistor and the B bar transistor are joined. So I'll mark here drain and drain. Next thing is that this is the B bar transistor and this is the A bar transistor. So in the NMOS side, I see that the source and the drain are matched. The source of the B bar and the drain of the A bar are joined. The next thing I see that A bar and B, what is joined? The source regions. So I connect them. The remaining is the drain region, and here it is the source region. Similarly, we'll see for the CMOS. The next step is to connect the VDD and the ground. We see that the source and the source region that is here are connected to the ground. So we can mark a connection and connect it to the ground. And we see that this drain and the source, this one, is connected with this drain, and the source is connected with this drain and this source. So the drain of B is present here at the last, and the source of A. Okay. Now for the output, we have to see from where we are getting the output. We are getting the output from this terminal, the drain of A and the B bar. We are making a connection and we are making it to the output terminal. Okay. Now for the PMOS, we have to see that which terminal are coinciding. So we have the A transistor and the B bar transistor. So in this thing, the A and the B bar, the drain and the source are coinciding. So I'll mark here drain and I'll mark here source. Now the B bar transistor and the A bar transistor, both the drains are the joint. So the drain and the drain. And in this A bar and B, what are joint? A bar and B, again the drain and the source are joined. So the source of A and the drain of B, as you can see. The remaining is the source. So what else we have here? We have to connect them to the VDD. Which terminals are connected to the VDD? The source of A. So this is the A transistor. The source of A is connected to the VDD. Okay. And the source of B. Where is the B transistor? This is the B transistor. The source of B is connected to the VDD. And we have to see what is connected to the output. The B bar and the A bar's drain terminal is connected to the output. So it is connected to the output. This completes your stick diagram. Now this stick diagram can be used to draw the layout of the circuit. Now before we proceed with the layout, these are some color conventions which has to be followed while making the layout. This color convention I have taken from one of the video of one professor whose link is present in the description below. The green for the N diffusion, the brown for the P diffusion, the red for the polysilicon, blue for the metal 1, purple for the metal 2, and black for the contact. So I'm going to start making the layout. So first of all, we have to keep in mind the stick diagram which we have made. This is the stick diagram which I have made now. So first of all, we have the VDD and the ground layer above and below. So we have to take the metal one, that which is of blue color, and mark the metal and the ground pin. So this, now after marking the metal pin and the ground pin above and the below, we will make the PMOS stack. Now there is a PMOS stack of transistors. Okay, PMOS. Then we will make the NMOS stack. The PMOS stack is made with brown color and the NMOS stack is made with the green color. Okay. Now this is the NMOS stack. The PMOS stack and the NMOS stack. Then next we have the polysilicon, which is made of red color. So we have 4 transistors. So we will equally space. Now after marking 4 polysilicon layers, this can be named as, we can see in the stick diagram, A, B bar, A bar, and B. Now we see that this source of these 2 terminals is connected to the ground terminal. So for that I will take the metal layer which is of blue color and join it. After joining the metal layer with the ground, I will see that this is connected with the VDD and this also is connected with the VDD. So these 2 sources must be connected with the VDD terminal as shown. This is for making the contact. So there are certain rules that what should be the width of this metal and the polysilicon, which can be seen in the video which I will provide in the description below. Okay, and now we see that this source and this drain source and this drain are connected, but we will use a metal 2 layer for that because the metal is overlapping here. We also need one connection for the ground. So I will use the purple color for that metal 2 layer as stated in the color conventions. This one and this one and the last one. The metal 2 width is greater than the metal 1 width, which can be seen in the video of the rules which will provide in the description. Now the last thing is left is to make a connection for the output. So take one wire from here and one wire from here and make it for the connection for the output. I will again use the metal 1 layer which is of blue color. So and here is the output pin and one from here. So make the contacts with the black color. So here it completes the layout, and we can see it verifies the stick diagram which was made earlier. Okay, so this is a rough sketch I have drawn for a fair sketch also. This is for the video. It is a rough sketch. It may look like this if you properly draw it with the length, proper length given in the design rules of this. Thank you.